Good morning and welcome to SQL Security. I'm happy to see that so many of you have found your way to this remote corner of the conference center. That's great. My name is Joachim Hammer, alongside my colleague Jakub Szymaszek. We are members of the security team in SQL, and the goal of the session today is to check in with you, give you an update on some of the important features we've been working on over the last 6 to 9 months or so, and just give you an overview, get some feedback from you, and we'll see how it goes. We'll keep it very informal, and our plan is to let the demos do most of the talking here, so we'll see how that goes. Just one more quick thing. We in the security team, we deliver features into all the release vehicles for SQL. So you'll hear us talking today about SQL Server, the on-premise, the box product, but we'll also talk about SQL Database, of course, that's our PaaS offering. And then there's sort of the SQL running in a VM. So whenever there's a distinction, we'll call it out. In most cases, our goal really is to make sure that security works the same way across everything. We're not there yet, but so just a quick heads up. We'll talk about features that might end up in different vehicles. We'll make sure we'll call it out so there's no confusion here. Okay, I'm going to jump right in. So the security investments that we've made over the past and will continue to make roughly fall into sort of 3 categories. There's the data protection. There's the work that we're doing on encryption. And so there it is. There's sort of 4 areas here that we'll call out today. Always encrypted, of course, is something that we're really proud of. It's new. You may have seen it in the foundation session on Monday with our directors. So we'll talk a lot more about that. We're going to talk a little bit about investments in TDE, and this is one of those features that we've had in SQL Server for quite a while, since 2008. Just a week ago, we released TDE for SQL Database for our PaaS offering. So I'll quickly talk a little bit about this. We also made some improvements to TDE overall that will benefit TDE in all versions, namely around perf. So to those of you who've used it and didn't think that the perf overhead was tolerable, give it another try. We're essentially taking advantage of Intel's NIS hardware acceleration. So we're doing the decryption and the encryption on the chip in hardware. So that has resulted in roughly 5 to 8 times performance improvement for the encryption, and I think about 8 to 15 times better for decryption. Now, of course, these numbers vary. It depends on your workload, but we've measured some significant improvements, so give it another try. This is coming in SQL 2016 as well as in the cloud. Also quickly, we've done some work on our crypto functions, crypto libraries, and here the goal really was to bring all this up to the latest standard, as well as help improve password strength. So, for example, we are going to release the ability to do multi-round password hashing with a customizable number of iterations. We're making sure that we're using AES 256 everywhere. We're increasing the password length. And then we're also working on improving the security of TDS. So we are, by end of this year, we want to be in a position where you can use TLS 1.2, the latest version, across our stack with SQL Server, SQL Database, across all the clients. And then last but not least, CLE, that's our cell-level encryption, or sometimes also referred to as our crypto functions or crypto libraries. This is available in the cloud now in our PaaS offering as of a week ago. So we had a little announcement there in case you missed it. So with TDE comes CLE in the cloud. Again, not our most popular feature, but for some of you who need it, really do need it, it's available in the cloud. So that's the encryption bucket. There you go. Auditing is also a very important feature for our customers. So we are making continuous improvements to auditing, and that includes both SQL audit in the cloud, where our team in Israel is continuously working on improving the reporting and analysis capabilities. So at the end, I'll show you, I'll give you a little sneak preview of what this integration of SQL audit and Power BI might look like. So there, the big thing is you'll be able to, once you configure audit, your logs go into a storage account, you'll be able to tie this in with content packs from Power BI to do a whole lot more than just sort of visualize your logs. So that's a big thing. And then for SQL Server, we are continuously staying up to date on our compliance and certifications. And so there, the big thing for us was to make sure we're staying current with common criteria. We are adding the ability to audit the outcome of transactions. So from now on, in addition to being able to sort of do the permission checks, you'll be able to audit whether or not a transaction succeeded or whether it rolled back. So that's coming in audit for SQL Server 2016. And then, oh, there it is, sorry. And then the last bucket, these are delighters for hopefully for our developers, app developers. We finally have row-level security available, and as you may have seen the announcement in late January, this is now running in the cloud, so you can use row-level security in SQL database. And we also have data masking, dynamic data masking, another feature that has generated a lot of excitement. Also available in the cloud. Both will come to SQL 2016. So when the first sort of community preview is coming out later this summer, you'll see them in SQL Server. You can give them a try. So that's the overall sort of scope of what we'll talk. And so today in this session, Jakob and I will focus on always encrypted. We'll focus on RLS. We'll talk a little bit about TDE. We'll talk about data masking. And then at the end, I'll give you that glimpse of what SQL audit looks like with Power BI. So that's the scope for today. And as I said, chime in with questions anytime. And so there's that. And here we go. So always encrypted. We've gotten a lot of interest, a lot of questions already. This is available in both 2016 and in SQL database. As I said, check in with us early summer or so. You'll be able to do some early sneak previews here. Before I go into more details, and Jakob will have a demo there, let me just give you a quick overview of sort of what this is and why you might be interested in it. Essentially, if you think about it, it fills the gap between TDE, transparent data encryption, the encryption at rest, and the encryption in flight, in the sense that it puts you firmly in control of the key. You encrypt the data, and the data remains encrypted throughout the life cycle outside of the trust domain, including in memory when SQL Server is operating on it. So that's a big help in preventing information disclosure. In order to do this, we'll have to be able to support the ability to query encrypted data, because as I said, you have the key, you control the key. Data doesn't have to be encrypted outside of your trust domain. So the ability to query encrypted data was a cornerstone of this feature. And then finally, application transparency. What this really means is that you don't have to re-architect, redesign your application to take advantage of this feature. So the secret sauce is in the client here. So this is really client-side encryption and decryption. So the client driver plays a very important role in this in conjunction with SQL Server, and you'll hear more about that in a few minutes. You keep the key. There is another important ingredient here is the encryption algorithm itself, because as I mentioned, you'll be able to query this encrypted data. So clearly AES 256, the sort of random encryption that we have already, doesn't work there. So we have a new encryption algorithm. And then the transparency is really important, the ability to do this without the application being involved here, which makes it very different from cell-level encryption, for example, or any type of encryption that you do through the application. So let me show you how this works in sort of broad strokes, and then we'll see a demo shortly. So assuming we've got this set up, let's say we have an app. We've got our special ADO.NET client there interacting with SQL Server in the back end, and we have a database there. It's a customer table, and we've decided that, and I mentioned this as column-level encryption, we've decided that the most important columns, or the columns containing PII information-sensitive data, are the name column and the social security column. So we encrypted them with always encrypted. And let's just take this at face value. We'll tell you how all this works in a minute. So there it is. So the application continues to interact with the backend as before. So in this case, it wants to do a lookup on social security number. So it emits that request to the client driver. Now, the secret sauce is here. As I mentioned earlier, the client driver, in some handshake with SQL Server, understands that there is encryption in the background. So it transparently encrypts that query, that request, and it encrypts just the right parameter here. In this case, this constant, the social security number constant, encrypts it using the proper encryption algorithm, emits that query to SQL. And so the interesting fact now is SQL doesn't really know anything about always encrypted, really. It takes that query, it processes it just like before using the ciphertext, and what it finds, there it is, it produces a result set, and notice the result set is encrypted. That gets returned to the client, and then the client transparently decrypts the result, and what ends up over on the application side is a result set that you would normally expect there, namely some person that matches that social security number. So that's a high-level sort of workflow. I also mentioned earlier that there is something happening around the encryption algorithm. So with always encrypted, we are introducing a second type of encryption in addition to the randomized encryption that we have today. And what makes that special or different is that, and we call it deterministic encryption, is the fact that if you encrypt the value over and over again, you'll get the same ciphertext, which is, of course, not the case when you use AES 256, the randomized encryption. So that's the big difference here, and that's why we can support a certain type of operations with always encrypted. Now, with the first V1 that's coming out, it'll be equality only, which does sound a little bit limiting, but then if you think about the type of operations you do on these sort of columns like social security number, credit card number, there are a good number that are really just lookup queries. Now, this is our first foray into this, and you can expect a lot of iterations, and one of our main goals, of course, is to increase that set of operations. So you'll see a lot more coming out there in the next, over the next time. One more word of caution, the difference between encryption, the randomized and deterministic, of course, is the fact that it has these repeatable ciphertext. And so when you use always encrypted, there are some guidelines that you have to sort of think about, and we'll have a few more later. But one is that you need to think hard about which columns you want to encrypt. So if you take, for example, the column gender, which only has two different values, male or female or MF, that might not be such a good idea with the deterministic encryption because you'll see a lot of repeat values and probably easy to guess what those are. So that's that. Let me talk quickly about the keys, and then I'll turn it over to Jakob. Then I think you have a good understanding of where we are. Just like with every encryption feature that we have been releasing, there's a key hierarchy at play here. And so with always encrypted, you'll be dealing with two kinds of keys. There's the master key, we call that the column master key or CMK here, and this is the key that you create and you hold on to, you will not relinquish. SQL Server doesn't need it. This is yours to keep, and this is what protects everything outside of your trust boundary. That column master key will protect, it's an asynchronous key that will protect what we call the column, one or more column encryption keys. So I mentioned earlier this is a column feature, and you can protect each column with a different column encryption key. So the CMK protects the CEK, and this clicker. There you go. So you use the CMK to protect the column encryption key. And as I said, you hold on to the master key, and in fact, you get to decide where you want to store it. So right out of the box, we'll give you a couple choices. You can store it in your local cert store, or you can, you may have heard of Azure Key Vault. That's another option. You can stick that certificate there and leave it there. Or you can, we'll offer you the choice to actually use your own HSM and tie that in with all is always encrypted. Use that to protect the master key. And we assume that these first 3 steps are probably something that a security officer would do. The last step, and then I'll turn it over, the last step to enable this is to take the column encrypted keys which have been encrypted by the master key and stick them in SQL Server. And the reason we put them there is for convenience. It makes some of the algorithms easier, some of the workflow easier. But remember, the key is encrypted there, so there's really you can't do anything with it. So it's just a storage place. And that last step can be done by anybody other than the security officer, so there's a certain amount of separation of duties here built in. Okay, so with this, I'm going to turn it over to you, Jakob, and what are you going to show us?
Thank you, Joachim. Hi, everyone. So I will start with introducing our sample application that we are going to use throughout the demonstrations today. It's a very simple healthcare management system, which is still under development, by the way. The system which allows you to basically manage information about patients at a healthcare clinic. Okay, so that's what you see on the left-hand side of the screen. And on the right side of the screen, there is a SQL Server Management Studio, which I'm using to connect to the database that feeds the application on the left. Okay. So this database has a number of tables, but there is one table which is particularly interesting for this first demo. That's a table named patients. So as you can see here, this table contains some sensitive information, including social security numbers of patients. And as a user connected to the database with SSMS, I'm connected as a DBO, database administrator, I can actually see that sensitive information, including social security numbers. And this is the problem that we want to fix. This is the problem we want to address. And throughout this demo, I will show you how you can leverage Always Encrypted to actually address this issue and make sure that your sensitive data, including social security numbers, is protected. And no one connecting directly to the database who doesn't have the proper keys and Always Encrypted properly set up can access that sensitive information and see it in plain text.
And okay? TDE wouldn't help in this case, right? TDE?
It wouldn't because with TDE, the data appears in memory of SQL Server the moment it is loaded from disk, and everybody who connects to SQL Server using tools like SSMS can, of course, query arbitrary tables and columns and see data in plain text, okay? So here's what I'm going to do. I'm going to create a new version of the database, and we just set up to use Always Encrypted. And then I will redirect the application you saw to use that new version of the database. Okay, so let me start. I happen to already have the pre-created empty database. I named it Clinic Encrypted. Okay, it has no tables, no data in it. It's totally empty. Okay, so the first thing that I want to do, since I know that I want to use Always Encrypted for this database, well, we know from the previous slides that we need to set up some keys. Okay, so and we have two types of keys: column encryption key and column master key. We added some tools to SQL Server Management Studio, which allows you to create those keys very quickly. We can start with either one. Basically, there is some kind of a guided experience, so you can pick any of these keys to start with. I will start with column encryption key. So the first thing that I need to do, I need to name this. I need to name this key. Okay, that's the name that I pick. And as we know from the previous slide again, a column encryption key needs to be associated with a protecting column master key, okay? So, well, I don't have any master key defined yet, so let me define it. Okay. And in the process of defining the master key, I need to pick where my master key is going to be stored, okay? So what I'm going to do here, I'm going to pick a pre-existing certificate that exists in a certificate store on my development machine and use it as a master key. So I will traverse my certificate store and pick one of these existing certificates. By the way, when you are trying this feature out, hopefully a few weeks from now, you don't have any certificates or in your development test environment, you can quickly generate a self-signed cert for development purposes and use that. But for now, I will use a pre-existing certificate stored in the machine store. So let's pause here for a moment. One thing I want to call out, so what you are seeing here in this demo is a first batch of tools that will accompany this feature and which will release early summer, a few weeks from now. And the purpose of this first batch of tools is to basically help you get started with this feature, start testing it, evaluating it. Going forward, we will incrementally start adding more tools, enrich this tool set to support scenarios like deploying encrypted databases to production and managing keys in the production environment. Okay?
Yeah, there's quite a bit of stuff to manage here, right? So we've talked about the keys. We'll talk a little bit about how the data flows back and forth. So I think, yeah, so that's good. Let's continue and see what else we've got.
All right, so back to the demo flow. I have my all the attributes of my master key selected, so I click create, and the next step when I click this OK button, several things have happened. So first of all, the new plaintext column encryption key got generated, then it got encrypted with the master key that I picked, and subsequently the metadata about the encryption key got uploaded to the database. Okay, so and you can now view these keys, access them in the Object Explorer. You can also inspect the catalog views that capture metadata about these keys, and I emphasize the fact that we store all this encryption metadata in the database and catalog views, because you will see later the important role this metadata plays in the query processing workflow. So we have two simple queries here that extract the information about the keys we have just created. So there is a column encryption key, information about column encryption key we created, and the bottom part of the screen we can see that there's the encrypted value of that key. Again, we don't store plain text values of encryption key, only encrypted values. We can see that this key is encrypted, got encrypted with a certificate stored in the certificate store. So what this statement implies about the master key is that there is a requirement that each client machine that wants to access sensitive information stored in this database needs to have access to that master key, needs to have access to that certificate. Okay? All right, so at this point we have a database still empty, but at least it has two keys we configured for always encrypted. Okay? So in the next step, we'll create a schema which has some columns that correspond to sensitive data encrypted. Here I created a very simple T-SQL script that simply recreates the schema of the original database, which you saw at the beginning, which contained plaintext values. The only difference between this new schema and the new database and the schema in the original source database is that some columns are configured as encrypted. So, for example, for social security number, what we are expressing in this line using the new syntax we have introduced in the create table, alter table statement is that this social security number column is going to be encrypted with deterministic encryption. And I pick deterministic encryption because I want to be able to look up patients by social security number. So I need equality comparison support here, right? And then we say we were encrypting this column with AES 256 algorithm. We'll add more algorithms later on. For now, that's the only algorithm that is supported. And we say that this column is encrypted using the key we just created. Okay? And similarly, another column that we picked was birth date. And here we happy with randomized encryption because we don't plan to do lookup operations based on birth date, so randomized encryption is adequate. Okay?
So this brings up a good point. So when you create the schema, you have to really understand your workload. You have to make sure you understand which queries sort of touch which portions of the schema, because one thing we don't want is you to just go and encrypt everything with always encrypted. I mean, there's a tendency to say, yeah, what's good for one column may be better for all the others. This is not TDE. This is really a column-level encryption, and the overhead is significant, so you don't want to just go ahead and do everything with always encrypted, right?
Right, precisely. Plus, again, at this point, we have certain constraints regarding, for example, the types of operations you can perform on these columns. So if you encrypt the column using even deterministic encryption, you won't be able to perform pattern matching or other operations. So that's one of the reasons why always encrypted, we recommend, should be ideally used in tandem with transparent database encryption. Okay? So good. Then you get the highest level of protection for these sensitive data columns, at least. Right?
Okay.
So let me run this script, which again creates the schema with encrypted columns. The last statement in this script is the query on syscolumns catalog view, which again shows the metadata for encryption-related metadata for these two columns, just to confirm that my intentions expressed in that DDL you just saw got implemented. Okay, so at this stage we have a database with keys and the empty schema. Okay, so the next step, in the next step, we'll migrate the data which is stored in plain text in the original database you saw at the beginning to the target database, which is empty and which we just created. Okay, so for that stage, for that step, I will use the existing tool you might be familiar with, the import-export wizard, which, by the way, we haven't changed at all, which illustrates the transparency aspect of this feature. So what I'm going to do with this tool, I'm pointing this to the source database, the plaintext database, nothing unusual here. Then I'm pointing it to the target database with always encrypted setup and no data. There's one interesting thing I want to call out here. So this tool automatically picks up a new keywords that are available in the underlying .NET framework, ADO.NET driver in .NET that we are using here. And there is one new keyword that we have added for this feature. It's called column encryption setting. And when I'm connecting to the target database here, I'm setting this keyword to enabled. Okay? And this has actually, you're going to see it in a moment that it has quite a vivid and important effect. So what this keyword implies is that when this tool establishes the connection to the target database, it will use always encrypted feature on this connection. Okay? So what it means that this tool will transparently encrypt data that are being imported into the target database. Okay? To be precise, the driver this tool uses will do that transparent encryption of data of the data that are being inserted to the columns that we configured as encrypted. Okay? So let me continue with the wizard steps. I will move all my tables. Again, for now, the most interesting table for us is the patients table, but I want to migrate all my tables here. Okay. I have an option to save this workflow as an SSIS package. If I want to reuse this, repeat this operation later on, this can become handy. By the way, if you attended the session on Monday, SQL Server Revolution, this was what Rohan did in his demo. He basically showed he had the pre-existing SSIS package and he used it to quickly populate the encrypted database. So that's what you can do as well. Okay, so let's go with the wizard steps. Okay.
So while this runs, so again, the unfortunate part here is that we can't just go ahead and click on a column and do an upgrade, an in-place upgrade, or just say, okay, populate the schema here. Unfortunately, this workflow, it looks a little complicated, and it is complicated because, remember, encryption happens, decryption happens outside of SQL Server in the trust boundary on the client side. So that means if you have data in SQL Server, if you want to use always encrypted, you have to bring it outside and then bring it back through that client driver and load it that way. That's the unfortunate side effect of the security that you get by using always encrypted. So.
All right. Okay, so now we have data in our encrypted database. So let's see what is the difference here. So let's actually revisit and remind ourselves what is the data that we store in the plaintext version of this database. So that's how the data looks like in the plaintext version of the database. Now let's see what we have in the new encrypted version of the database. So we have social security number and birth date as expected, encrypted. These values show up as var binary blobs. These are encrypted values. Okay. So we are done with the database at this point. Now let's fix the application. So the application still points to the original version of the database with containing plain text. So let's redirect it to the new database we created. Okay, so let me quickly modify the connection string in the web config file. I'll do that in 2 steps. So first, I will point this application to the new database, and let's see what happens. Okay.
Should work, hopefully, right?
It should. Okay. Well, it kind of worked. So I temporarily, hopefully, broke this application. So what happens here is this application runs the same select star from patients query that you just saw in SSMS, right? And it also behaves as SSMS, which is it receives ciphertext, var binary blobs, and these var binary blobs are not decrypted transparently yet, which was what we saw in SSMS. And this is because we haven't configured this application yet to use always encrypted properly on the connection to the database, okay? So let's fix that part. So again, we can fix it very quickly using that familiar keyword that you saw in the previous part of the presentation. So I want to emphasize this because it is quite important and demonstrates the power of this feature. The only change I'm making to this application is adding a new connection string keyword and its value to the connection string column encryption setting set to enabled. So when I do that, when I save this, I'm missing. I'm missing the letter C. Oh, you're right. Thank you. That
Very
would
good.
mess
This is
up
a
my
test.
demo. Thank you. Right, so let's try to refresh that. Okay, so it worked. So let me again emphasize and explain what happens here. Again, the same select star from patient's query. The difference is that now the client, the driver, and the server engage in a dialogue. And during the dialogue, the server sends all this metadata that I showed you before as part attached to the result set of that query. And that metadata allows the driver to transparently decrypt the results and present the results in plain text transparently to the application. Okay? But, okay, there is more here. One more thing that I like to show is kind of a flow of data in the reverse direction. Okay? So here I have the profiler that is attached to the database. Let me actually make sure it is correctly attached and captures all the events. So what I'm going to do here is I will click on the social security number of that patient, and this will trigger a query, and that query will do filtering based on that social security number and produce the list of visits for that patient. So again, as you can see, in the application, the social security number is in plain text, okay? But here's what the server sees. The server sees the same social security number in ciphertext. So what happens here, the client application, the client driver transparently encrypts that social security number and sends the encrypted value to the server, which again proves that with this feature, the server never sees the sensitive data corresponding stored in encrypted columns in plain text. All right?
Very good. Quite impressive to get this all sort of coordinated like this. As you can see, there's a whole lot of stuff happening behind the scenes. We're not done yet by any stretch of the imagination. We're not done yet on the tooling. There's a lot of things we have to make simpler. What we're hoping with this first version that's coming out, we want you to try it and give us your feedback on what you like, what you don't like, and we'll keep iterating. We'll promise this is something that we're really investing heavily in. It's not for everything, not for everybody. Again, you have to use it with some grain of caution here, but it's another tool in your tool set, and we hope you like it. So, great. Let's go back to our show here. Yes?
Can you speak a little bit about the effect on indexing with both humanistic and
Oh, sure. The easy answer is indexing works just like before if you choose deterministic encryption. Again, if you choose the random encryption, of course, everything is off. It's really just encrypted and it sits there. Deterministic encryption, you get the ability to do equality. You can index your column. Equality also means you can do joins, you can do grouping, you can do duplicate removal. So there's a few things that work, and then the next set of operations will come. Good question. Thanks. I'm sorry?
pattern searches as well?
What kind of search? Oh, pattern searches unfortunately won't work. In neither. So again, randomized encryption, absolutely no support for operations at all. Deterministic encryption, that's some so like operator, pattern matching stuff is going to come in the next version. I know this is an important one. No, it'll fail. So if you have an operation in there that's not supported, including arithmetic, like range sorts and all those things, they will fail. So they'll fail explicitly. Yes? You don't explicitly do this. You have the master key on the client. You generate the encryption key, which gets protected and then stored. The client driver will, underneath the covers, make sure that the key flows to the right places, including retrieving it from SQL Server, because the key is needed to do the encryption and decryption. But you don't have to.
One thing that perhaps maybe that's what you're asking about.
It seems that you created the key on the SQL Server.
Oh, no. The key was created on the client side. and then it gets uploaded into SQL Server.
I just want to add one thing, that you have an option to actually store your main key, your master key. You do not have to store it on the client machine. You can store it in an arbitrary store, and we'll have the provider extensibility, provider-based mechanism to support that.
Yes?
You uploaded the key to the SQL Server. If you're using Always-On, do you have to load the key to all the replicas?
They will be replicated automatically through the replication mechanism that you use.
So even
Right.
if I don't have a contained database, it would be able to, because it's in the database object, it would get replicated across.
Correct.
Yes. Just like with TDE and some of the other key hierarchies, they get dispersed automatically behind the covers. Okay, let's switch gears a little bit and talk about row-level security. Row-level security, as I mentioned, it's there. You can try it out in SQL Database. And this is one of those, we hope, customer delighters that helps you build better, more secure applications. Really what it does, it gives you fine-grained control over who can access rows in your table, in your tables, based on the on properties, on characteristics of the user that's accessing the database, that's executing queries. So there's various ways you can pass that context to the engine and let the engine evaluate it. We'll talk about that in a second. Another one of those features, completely transparent to the application. We'll show that to you. It almost looks like magic. You have a policy, you have it off, you can see all the rows, you turn it on, same application, same interaction, all of a sudden you see a filtered set. Completely transparent. And another benefit of RLS, the ability to create these security policies, we call them, and store them in the engine centrally rather than having that code dispersed throughout your application. We realize that you can you don't need RLS, you can implement it yourself, and many probably have done that. You can use app logic, you can use views and triggers and so forth. But there's something to be said for taking your logic, putting it in a single place, attaching it to the table that needs to be protected, rather than having to hunt for it. So what we've added with RLS, row-level security, we've really added a sort of hierarchy of concepts. Let me quickly step through them, and then we'll look at a demo. So there's, at the lowest level, there's what we call a predicate function. It's an inline table value function that encapsulates your filtering logic. And that logic can be as complex as you want it. It can have joins. You can join with other tables. You can create special tables just to do your filtering. And the reason we chose an ITVF is because that allows you, it's optimized to give you the same kind of performance that a view would give you. And I mentioned views earlier. A lot of you probably use views to do some form of row-level filtering. It's essentially, at query time, it gets, the logic gets expanded and added into the query, just like a view would get expanded. So performance is similar to that of a view. Then this predicate function gets bound, schema bound to the table that you want to protect in what we call a security predicate. And actually, I forgot to click here. So there's the predicate function. There you see it highlighted. And then this predicate function is bound to the table. We're using schema binding, which has the nice side effect that it actually, once bound, this predicate protects the table from being altered, so especially the columns that you're using in this predicate. So here in this case, start, end time, and wing, you can't go after the fact and try to drop one of these columns or alter them. They are fixed, they're protected, so you can't, this helps sort of prevent circumnavigating these policies. And then finally, as I mentioned, the security policy is basically a management container for all your predicate functions that you create. And that allows you to turn them on and off. It's a simple transaction, and the table is protected. So let's jump right in. And, okay.
Oh, Did I cut you off? Or?
Nope, no, perfect. And so we're continuing with this example, and one thing we want to show is that these features actually work together. So I think we're going to still use always encrypted, right, and go from there.
Precisely. So basically, we continue. We're going to build on the same application, the same database. We just encrypted with always encrypted. So as you saw in the previous part of the demo, what we did, we made sure that database administrators or whoever connects to the database and doesn't have the right key or is not using always encrypted on the connection cannot see data in plain text. So that's great, but there is another problem with this application. So the problem here is that, well, I'm right now connected to this app as a nurse Ratchet. And, a problem here is that I can actually see all patients, including their sensitive information, all patients, even those who I'm not taking care of directly, patients of other nurses or doctors as well. So what we really want is for Nurse Ratchet to be able to see only her patients. Okay, so let's see how RLS can help solve this problem. Okay, so here in this database we have a few other tables, as I mentioned earlier, and one of them is the staff assignments table, which basically keeps the association, keeps the mapping of the members of medical personnel to patients. Okay, and so we can actually see what this mapping is. So Nurse Ratchet has 2 patients, right? So ideally you want that this particular nurse, when she connects to the database using the web app, these are the patients the nurse can see and no other patients, okay? So let's see how we can accomplish that with RLS. So here I have a very simple predicate function. That predicate function takes a patient ID as input, and it retrieves a staff member ID from a context info. Okay, and based on these 2 pieces of information, it determines whether the given staff member, a member of medical personnel, can access information about the particular patient or not. Okay, so let me actually instantiate this predicate and policy using it. Okay, and let's see what difference it made to the application. So again, I'm connecting as Nurse Ratchet, and here it is. I can only see my patients. I cannot see other people's patients. Okay. Okay, Joachim, back to you.
Great. So that's terrific. And one thing that Jakob pointed out there was the ability to use the context info session parameter, because I think the application is always connected as some application user. That allows you to sort of differentiate who's connected, who's using this app, and then do the filtering based on that.
And we can, of course, do much more complicated logic in these predicate functions. We could filter on a wing or time, day in a week, or so on.
That's right. We've got lots of sort of samples and help out on our blogs on MSDN. So if RLS is something that's interested to you, then I'll encourage you to check it out. If you have any questions on any of the features, you can email us. We'll get you in touch with the right people. Let's see, there were some questions. Yes? Sorry, it's context. So I think the question was, is context info new, or has it been there? It actually has been there, and it's been unusable for you because we've had it, we used it internally. But with the new Azure SQL DB, the V12 servers that have come, this is actually, we freed that up. And so you can utilize that. If you look it up on MSDN, it shows you. It's a little bit limiting, and we'll have something to say about an improvement of context info over the next couple of weeks or so. We're going to make it a much more, much richer property bag that you can use so that you have a little more freedom in how you want that session parameter. Okay. Good. So that was RLS, and again, RLS works with always encrypted. The next feature we're going to talk about briefly is transparent data encryption. Again, as Jakob mentioned earlier, this is something that just because we have always encrypted now, we're not interested in this anymore. On the contrary, it's very critical. A lot of folks have pinged us repeatedly, hey, where is it? We need it for the cloud. We need it badly, even though it doesn't really add a whole new layer of protection, especially in the cloud. It's there for compliance reasons. That's what we hear the most sort of pressing need is the ability to say, yep, we've got the encryption at rest taken care of. In fact, SQL database does it for us. I turn it on, it's there. So that's really what we've been sort of driving for here. There isn't a whole lot to say about transparent data encryption, and I think that's a good thing, at least in the first version. It's based on TDE that you've seen and known from SQL Server for quite some time. It uses the same industry standard AES 256 database encryption key to protect your database at rest. It protects all your backups. It protects your transaction logs. It protects TempDB. And in the cloud, in the first version in the cloud, it does though without bothering you with any key management. So the service takes care of the certificates, making sure the certificates are in the right places. We create the database encryption key for you. All you do is you turn it on, you click save, and you're done. So there's this two-click user experience, and in fact, the team back in Redmond who's been sort of working on TDE has earned the nickname the click-click-done team because it was so easy. Now, in earnest though, whenever there's a feature that's really, really easy to use, probably means there's been somebody's been somewhere and working really, really hard in the background to get you that sort of easy experience. And this is the case with TDE. This is why it's been taking us a little bit of time to get it out there. There was significant engineering work to make this happen in the cloud in light of the fact that we have a multi-tenant system, we have HA built in, and we give you all these great features like geo redundancy, so the GeoDR features, the geo backups, all of these features that require movement of your database, your server, not just within a data center, but also across geo regions, and make sure that this TDE feature works. That was a big chunk of work. So the benefit to you, of course, is you turn this on, and you can use this with your backups. You can generate a geo-redundant server somewhere else, somewhere on this globe, and TDE still works. All of this, we think, is goodness, on top of the fact that, you just turn it on and it works. Now, we keep hearing a lot of questions on, okay, I actually like the fact that I don't have to deal with the certificates and the keys, but in some cases, I have a lot of databases where this applies, but then I also have a database or so that's really important to me, and I want to make sure that I'm in control of the cert. I can rotate this cert whenever I need to, rather than rely on you. So rest assured, we hear you. We are working on a subsequent version of TDE. Again, we'll probably can expect an announcement sometime later this summer that would allow you to do that will give you that type of control. Until then, think of this as an easy to use, you turn it on, you forget about it feature, and it gives you the assurance of transparent of encryption at rest, and that's really what it's intended for. It's available in all V12 servers and across all the tiers, which is another thing I forgot to mention earlier. One of our goals is to not differentiate when it comes to security anymore. So whether or not you use a basic or a high-end premium, security is something that you should get no matter where you are, no matter what edition you use. So you can expect all these security features eventually to make their way across all the editions. Let me show you a little demo here, this click-click-done demo. And I think I'm number 8, yeah. So here we are. This is the familiar portal. This is the Azure Preview portal. And we're looking at a sample database here. It's called Ignite Demo. And if you click on Settings for this database, you get this pane on the right-hand side that has a bunch of options for properties. Here's your geo-replication. You can turn auditing on. We'll come to data masking in a few minutes. And then here is transparent data encryption. So when you click on this, we'll have a new window there for you. If you use it for the first time, since it's a preview feature, you'll have to accept the preview terms. That's the top button here. I've done that already, and that's just a legal disclaimer. And so then here you see the incredibly complicated user experience. You can either say on or off. And so you click on, and you click Save. And what happens now is, underneath the covers, and those of you who used TDE in the box before, you know there's an encryption phase, and then there's sort of the steady state. So when you click on, the encryption kicks on, and depending on how big that database is, how much data you have under storage in this database, this initial encryption phase can take a little while. And so it churns away, and you can expect a higher perf hit during this encryption phase. Once it's done, it enters sort of the steady state situation where information or data gets encrypted, decrypted on demand. So every time you process a query, a page gets loaded into memory, gets decrypted, operate on it, and then when it's written out, it gets encrypted again. That's a steady state. The perf overhead in steady state is much lower, of course. We've done some perf measurements, and anytime you talk about perf, of course, it's a little bit harder to quantify exactly what your experience is going to be. It really depends on the workload. And the interesting thing is customers in Azure, in SQL DB, have such large variety now of workloads. We're seeing anything from the traditional OLTP to folks running heavy-duty analysis queries. So it really depends on what you're doing. Perf overhead is anywhere between 2% and 40% based on the test that we have done, and so you'll probably be somewhere there in the middle. Most cases, you'll be at the lower end, of course. And again, we have the Intel hardware acceleration built in now in the cloud as well, running. So that does help. So this was done. This was a very simple test database. It shows you it's encrypted here. What you can do is, so this is the portal experience. What you can do, though, is you can also do the same thing in T-SQL. And again, here is, I've highlighted, here's your sort of two-click experience, the equivalent to that. You do the same thing. You create your database encryption key, and then you say alter database, set encryption on, and that's all you do. And then we have a DMV here for you that allows you to sort of check and see what's happening. And if you run this, I don't know if you can read all this, you'll see we have encryption status here. This is the second column. It shows a 3 in there. If you remember your DMVs from the box, 3 means it's encrypted. There's 1, 3, 4, and 5 different states. So TempDB, this is the DB-ID 2 is always TempDB, and 5 is this Ignite demo. So they're both encrypted. You can check it here, and then if you want, in the end, you can also use T-SQL to turn it off again. So that's TDE for you. Give that a try. As I said, it was announced a week ago at Build, together with CLE, the Selim level encryption that's there. So give us your feedback on this, and we hope it's useful to you. So, Jakob, what do we have next?
Well, data masking.
Okay. Let's go back to our slide deck.
One more.
So that was the TDE. So data masking. If you remember the overview slide, this was in the lighter secure application bucket. And, again, this is also a feature that's coming for both SQL Server 2016 and for SQL database. In fact, it's in public preview in SQL database. You can try it there. Really, the sort of the value proposition for data masking, and it's I should say it's dynamic data masking to be specific, is there's compliance, of course. Regulatory compliance is a big motivator for why you would use data masking, and then protecting your sensitive data. And the interesting sort of part here is that you can think of dynamic data masking as sort of picking up where encryption leaves off. So there's two forms of data masking. There's, to those of you who know this, and I'm not an expert, but there's static data masking, which is essentially replaces existing values on disk in your database with a set of data values that obfuscate the original result but retain characteristics of the data set. And then there's the dynamic data masking, which is really simply obfuscation of values on the fly. And in our case, a mask is applied to the result set after the result set is produced in the optimizer before it's returned to the application. So think of it as putting a veil over the data, and you get to define what that veil looks like to hide certain aspects of, let's say, a social security number or a credit card number, and it's designed to protect the data as it's being returned to the application, where, as you saw with Always Encrypted, of course, the data is in the clear text. Okay? So dynamic data masking gives you this ability to say, hey, let's say I'm a financial institution, I've got a bank, I know my data is protected. When it comes back to my app, I have different app users, and in some cases, let's say a teller, they don't really need to see the social security number of our customer or the credit card number or account number. It's okay if they see the last 4 digits, for example. So I'll put a mask on that. So this is really where dynamic data masking comes in. And Jakob is there, let's do a demo, and we'll see how we can use that in our application.
So in the previous part of the demo, we actually addressed 2 problems, right? We made sure that the sensitive data stored in a database is encrypted using Always Encrypted, and nurses, doctors who access patient information through the web app that you see only can access their patients, right? But here's another issue. So again, I'm logged on as a nurse, and I can see the list of patients, including the full social security numbers of the patient, right? So you can ask a question, does a nurse really need to have access, and does she need to be able to see a social security number, the full value of it? Well, probably not, right? So let's see how data masking can help to address this issue. So by the way, when Joachim was talking about TDE, I have redirected this application to the cloud version of the database, to the database in the cloud, which has the same RLS policy set up. So now I'm using the portal to interact with this database and to configure data masking in it. Okay, so similarly, in the same blade on the portal where you see transparent data encryption settings that Joachim demonstrated before, there is a data masking entry, and here you can access dynamic data masking preview blade. You can sign up for the preview, enable this feature for your database, and subsequently you can click on this plus here and start defining your masks, or add 1 mask at a time. So here's what I'm going to do. I'm going to define a mask for the social security numbers, stored in the patient's table in the SSN column. So here I can pick from a set of pre-existing, predefined masks, or I can define my own mask. So there is actually a pre-existing mask for a social security number. It masks all numbers, digits in the social security number except last 2. Well, let's do something a little more complicated. So we'll define our own mask, and and we'll mask all digits and the social security number except the last 4 digits. So I will define my masking padding. Okay, and I'm going to say that I want to mask the last 4 digits. Okay, so let's save that. Okay. All right. Now, what is different with this demo versus the previous demos, the effects are not instantly visible. It takes about 1 minute for these changes that I just made, this mask definition to propagate in the system. So again, we'll need about 1 or 2 minutes for these changes to take effect. So why don't we take some questions at this time?
That's a good question. So if we go back
Can you repeat the question, Joachim? I'm not sure everybody
heard. Yeah, so the question was, what happens when you apply these masks? Are they applied indiscriminately for this particular column to all the users, everything, or can you differentiate, just like in row-level security, that, hey, this person should be masked, this person shouldn't?
Yeah.
So if you go back in the portal, actually, we haven't reached the full sort of compatibility there with RLS where you can do masking based on context, session context. We do, however, have the option to define, and I don't know if you can see it there.
We call it privileged logins.
So you can define a set of users, principals, who shouldn't be masked. And you can specify it here in the portal, and that allows you to say, let's say, okay, everybody should see the mask except the database administrator or this group of users and so forth. So that's, at the moment, that's the current way to sort of differentiate about who this, where the mask applies.
But the users needs to be passed through some mechanism. The connection doesn't happen.
Right, exactly. So that doesn't work yet. That's a good point. So you have to specify this here. There's no connection string passing for you for the data masking there. Can row-level security and this be used with Active Directory security? So, good question. So we haven't really, at this point, it's all SQL auth, as you know, unfortunately. However, we're working hard on tying this in with Azure Active Directory, and give us a little bit. We'll have another announcement coming at some point, hopefully relatively shortly. Mm-hmm. Oh, you mean in SQL Server, for example? Yes, that works with security groups. So I'm sorry, I misunderstood. I thought we were talking about the cloud and tying in with Azure Active Directory. That's something we're thinking about, haven't announced that yet. In SQL Server, Azure, Active Directory in SQL Server ties in with row-level security.
So for example, you can specify a Windows principal or Active Directory principal as a privileged user excluded from masking, or you can integrate that and use these principles and roles when defining RLS policies indirectly. Okay, so let's see if our mask took effect. All right. Yeah. So you can see that now a nurse can see only parts of the social security numbers, okay, per the mask definition we created, okay. So to summarize these 3 demos, we ensure that data is encrypted, the sensitive information is encrypted database in using always encrypted. The server never sees social security numbers or birth date of a patient. We ensure that a nurse, a doctor can only see his or her patients, and we configured data masking to ensure that even these authorized, authenticated users see what they should see, what is required for their business daily work in terms of protecting Social Security number information. Okay.
Does masking affect the ability to query against that?
Nope.
It really does applies after the fact. So this is it's in SQL Azure DB, SQL DB. It goes through a proxy, and so query processing happens, and then at the end of the query execution, when the result set is produced, a mask is applied to the data. Now, there's a lot of stuff that's happening underneath the covers to make sure that you can't bypass the mask by sort of secretly copying something out in another column. So if there's a mask on Social Security number, you can't just sort of extract that and put it in TempDB in another column and rename that column and then query that column. So the masking is smart enough to catch these things, but it is really applied after the fact as the result set comes back. Yes?
I may have missed something. The last example that we saw was column level encryption still turned on?
No, it wasn't, to be frank. It's because, again, as I said, between the demos, I switched the database to the application to the target database, which was in the cloud. This feature is not enabled in the cloud yet, but it will be. Okay, so if you are asking, can I use always encrypted RLS and data masking together? The answer will be yes a few weeks from now.
Yep.
Was that it's the client that decrypts the CLE. So it needs to be the client that applies data masking.
Right.
Yeah, so the client driver is the one where you do the encryption, decryption. The data masking happens really, sort of think of this as happening in a proxy that's removed from the client. It doesn't happen in the client.
Right.
Think of it as happening as an extension of the engine SQL database.
The proxy, if the data is encrypted, how does the proxy know
Right.
the pattern is?
Right, so an encrypted field and a data mask field, they don't work together at this point, right? So because of the fact that we have the masking working through a proxy, this is what Jakob meant, coming soon, eventually we'll tie encryption and data masking together. Right now, what you can do, you can mask a non-encrypted field. This is the current state. Coming at some point, we'll make sure that they work together. We also switched, there was a little switch and bait happening. The first two demos were happening against SQL Server 2016, and then the last demos were happening against the SQL Azure database because of the fact that we don't have data masking on SQL Server yet, so that may have generated a little confusion. Couple questions here, yes?
Will both features work before the release of 2016?
Yeah, so you'll get these always encrypted. Masking and encryption on the encrypted field. We don't have a roadmap for that yet, so we don't want to commit this for 16 yet, but it's something we're working on. So I think we're almost running out of time here. Let me quickly wrap up. I wanted to show you, where did I put my clicker? And okay, so we're done with masking. We've done the demo. Let me just show you one quick slide. This is a preview of what you can expect in a few weeks. There's going to be an announcement. It'll allow you to basically configure SQL Audit and then generate a Power BI content pack, integrate your audit logs, which are in a storage account, with Power BI so that you can generate quickly dashboards like this that show you, these are the databases I'm monitoring. There's 4 here. You get to define events. They're called highlighted events here that you'd like to see. They could be events because they have an error code 14 in there, or they could be events where you have some number of unsuccessful logins, so you get to configure this. You can do drill downs on it. You can go and say, show me the events for the last hour, show me all the security events. So there's a lot of sort of rich content here that you can generate watch out for an announcement in a couple of weeks or so, and then you get to try this out as well. I'm going to close here with a quick set of some links that you can use where you find a lot more information. Most of the stuff on RLS is out there, always encrypted, is going to ramp up as we sort of release this into our community preview. We've got blogs, we've got documentation out there. So we hope this was useful to you. I'm going to wrap this up. Jakob and I will be here throughout the day. If you have questions, you can meet us over at in the expo hall at the booth, and then also email us with questions, and we hope we'll hear from a lot of you, and we'll hope that you will try some of this stuff and give us some feedback.
Right.
That's it. Thank you very much.